Hello, this is Travis Rogers, and my intent is to give an example of what it would look like if I were teaching um, multiplying whole numbers by fractions on the graduate level. This is going to be a 15-minute segment, and I chose to do the um, multiplying a whole number by fraction and doing the second half of that 30-minute block so that I can get some variety of um, mini lessons, if you will, within the lesson. I decided to do this about 15 minutes after I sent the revised version, so I apologize for any technical difficulties. I kind of just put together what I could, and I decided to go with it. So now we're going to match math to the story, and the story goes like this. There are 15 cars in Michael's Matchbox collection. 2/3 of those cars are red. How many red cars does Michael have? Now, this is a good time to point out, class, this is a good time to point out that similar to the last examples that we're partitioning, not iterating, which means that we are pulling out the fractional parts and really starting to examine those fractional parts. Now, who can tell me why I read this story, which is different than most of the other stories in which I allowed students to create that story? Thank you for sharing that. That's right, because I am assessing a very specific very specific criteria right now, which is having students be able uh, to show me that they can pull out math identifiers in abstract contexts. That's right. So let's go ahead and jump in. So we know that the story's asking us for 2/3 of 15. Of 15. That's right. Now, tell me, what is so important about the positioning of the 2/3 and where the 15 is? Thank you for sharing that. That's right. And it really has to do with continuing to give students more experiences with contextualizing the story to the actual math problem. And being able to write it this way allows us to really partition out those fractions. So another way to write this is 2/3 times 15. So the first step, of course, is an estimate. Now, we always want the estimate to have a range, but most importantly, that the estimate also comes with rationale of thinking. So who can share with me now, what would it look like in your class if a student was giving you an estimate with proper thinking? That's right. So what it would look like is a student explaining it and it can have a variety of ways, but one of the ways that I would know that they're heading in the right direction is if they said something between, I think the answer is going to be in the range of between 5 and 15, because 5 is a multiple of 15, and they said 2/3 of it, so it's probably a multiple of 5 that's going to be the answer. And that would tell me that the student is moving in the right direction of their thinking. So now that we have our estimate, we're going to set up the problem. Oh. And why is it important for the student to actually write down their estimate? That's right. So that they can go back and see how close they were. If they just say the estimate, then they won't be able to reference where they were or if they were moving in the right direction if they got a wild number somewhere. So as we're setting this up, we know that the whole is 15. So we're going to do that, and we're going to write that in the context of our fives. And we know to make a 10 box. And then we're going to make a 5 box. And that will get us our 15. To keep in line with the pre-knowledge that they know of 5s and 10s grouping in 5s and 10s. So the first thing we do is we have our whole and we have our picture match our math sentence. And we know that we're trying to find a fractional portion of the 15. So the math sentence should look like this. 3 into 15, and that would give us 5. And we know that because if we grouped our 3's of the 15, we would get, that's right, 1, 2, 3, 4, 5 groups. So if you saw a student give you this, would you say, if you saw your student give you something like this, what could you do to help them move to the next level if they thought they were done? That's right. Remind them that we were working with a fraction, and so we haven't explored the 2 yet, or the multiplying factor, or the multiplying factor of the fraction, which in this case is a 2. I'm going to erase that so that we don't accidentally think it's a negative 2. Just wanted to point it out there. So we know that we have 5 groups of 3 or 5 fractional groups. And our multiplying factor is 2. So that means we would have 5 fractional groups in 2 multiplying factor groups. So what it would look like is this. 5 times 2 equals 10. Whoopsie. Equals 10, which we would also see in our drawings. So what could you do to help the student get from just giving us the answer to then bringing it home? That's right, completing the math sentence, which is Michael has 10 red cars. That's right. And we want to make sure that we add the subject and then also the descripting factor, which is red cars. So that brings context to the math. Now, with the estimation, because of the particular numbers that we're working with in this case, they might say in their estimate 10. Now, give me an example where them saying 10 as the estimate would be would tell you that they're heading in the right direction, and give me an example where it will be telling you that they're heading in the wrong direction as it relates to an estimate. That's right. in an example where they are showing me their thinking, they're showing me their thinking by saying 5 is a multiple of 15, and 5 is 1/3 of 15. Therefore, if I doubled it, that would make it 10, and that would be the 2 pieces of the 3 pieces in the fraction. Something like that would let me know that they're heading in the right direction for their thinking. What would tell me that they're heading in the wrong direction of their thinking is if they went through here and then added 10 at the end. Or if they said 10 but they couldn't tell me how they got to 10, and that 5 is connected to 15 in a way that got them to 10. So really starting to stretch their thinking and hearing how it starts to move about is critically important to see where they're